Okay, so welcome back to part 2 of section 3.4, the chain rule, more examples. Here's our next example. F of x is equal to the fraction x divided by the cube root of x squared plus 4. I'm hoping you're seeing what I'm seeing. I'm hoping you're seeing, first off, we don't have a rule for roots, so we're going to rewrite this as x divided by x squared plus 4 to the 1/3. And then I hope what you're seeing is that we have a quotient rule with a chain hiding inside of it. Okay? Now I'm sure you remember, but just in case you have, maybe it slipped your mind momentarily, the quotient rule says that the derivative with respect to x of u divided by v is v times u prime minus u times v prime over v squared. Bottom derivative top minus top derivative bottom over bottom squared. Okay? So what we need to do now is we need to find out what u is, find out what v is, and make this whole thing work. So let's see. I've got that u is x, so then u prime is 1. I've got v, here's our chain rule, is x squared plus 4 to the 1/3, and then v prime is going to be 1/3 times x squared plus 4 to the negative 2/3 times 2x. Okay, so I've got u, I've got v, I've got u prime, I've got v prime. I should be able to put this whole thing together. F prime of x is going to be equal to, let's see, the bottom v, so x squared plus 4 to the 1/3 times u prime minus u prime, minus u, sorry, x times v prime, which will be 2/3 x times x squared plus 4 to the negative 2/3, all divided by v squared, which will be x squared plus 4 to the 1/3 squared. That's a hot mess, but I'm seeing something, and hopefully you're seeing what I'm seeing. I'm seeing 3 terms, and because I'm seeing 3 terms, here's my first term, there's my second term, both in the numerator, and a third term in the denominator. Okay? Remember, downstairs, when they're stacked like this, we're seeing that as an exponent of 2/3. Right? I'm seeing the same thing in all 3 terms. I'm seeing an x squared plus 4 here, an x squared plus 4 here, and an x squared plus 4 there. And so the way this works is we factor out the smallest exponent. So our exponents are 1/3, negative 2/3, and 2/3. So negative 2/3 will be our smallest exponent. So that's what we're going to factor out. So we got an x squared plus 4 to the negative 2/3 over an x squared plus 4 to the negative 2/3. That's what we're factoring out of both the numerator and also out of the denominator. Okay? When I factor that out of the numerator, what's left? So we're factoring that out. Let's see what's left in the numerator when we factor that out. Let's see, in the first term, if I have an x plus 4 to the 1/3 and I take out a negative 2/3, that's going to leave me with an x squared plus 4 to the 1. Minus, let's see, in that second term, I took this whole thing out, so I'm just left with the rest of it, which was a negative 2/3 x squared. And then downstairs, if I factor out an x squared plus 4 to the negative 2/3, I'm going to end up with an x squared plus 4 to the 4/3. That looks good. Okay. All right, so moving along, this is still f prime of x. Let's see. These are going to cancel. These parentheses are useless. And so my numerator is going to become 1/3 x squared plus 4. And my denominator is going to become x squared plus 4 to the 4/3. Now, there are some people who at this point will argue that this shouldn't be there. You should not have a fraction within a fraction. And so their argument would be multiply the numerator by 3, multiply the denominator by 3 to clear out those fractions, which would give us then f prime of x is equal to x squared plus 12 over 3 times x squared plus 4 to the 4/3. And there's our solution, our derivative of f, where we have a quotient rule hiding a chain rule inside of it. Now, what you'll probably notice about this is there's not a whole lot of calculus going on. I think we had a little bit of calculus here and here. And outside of that, there's just following a couple of formulas and then algebra to get to a final answer. So just be careful with that, because as the problems get more complicated and as we need to apply more rules, the math gets nastier and nastier and nastier. Now, whereas this problem was a quotient with a chain rule hiding inside of it, what's this one? This one's a chain rule with a quotient hiding inside of it. So I've got a function raised to a power. And when I have a function raised to a power, that's just an example of the chain rule. It's just the function is a quotient. So when I go to find g prime of t, it's going to be 9 times t minus 2 over 2t plus 1 raised to the 8th, and then I need to multiply it by something. But this something that goes right here, this piece right here, that's where the quotient rule needs to show up, because it's the derivative of the inside, which is the quotient rule. Right? All right, so I'm going to erase all this, and since I know what I'm looking for now, I'm going to go ahead and get that piece first. So if I'm looking at this inside piece, I'm going to call u the numerator. That's going to be t minus 2. So then u prime would just be 1. V is going to be 2t plus 1. So then v prime is just 2. And now that I've got all this, I can use that to put together the quotient rule. So then g prime of t is going to be 9 times t minus 2 over 2t plus 1 raised to the 8th times, and now here's where the quotient rule comes in, the bottom, 2t plus 1 multiplied by the derivative of the top minus the top times derivative of the bottom over the bottom squared. Okay, now I'm comfortable with this and this, but I am uncomfortable leaving this like this. I need to clean that algebra up. So g prime of t, 9 t minus 2 over 2t plus 1 to the 8th times, let's see, in my numerator, when I distribute, I'm going to have a positive 2t in the first term and a negative 2t in the second term. So that's going to be, they're going to cancel each other. That'll be nice. I'll have a positive 1 in the first term. Maybe I should write all this out. Distribute here, I'm going to get a 2t plus 1. Distribute here, I'm going to get a negative 2t plus 4 over 2t plus 1 squared. I don't know why I keep writing that denominator weird. Okay. In that numerator, these are going to cancel, 2t and negative 2t. I got a 1 and a 4, that's a 5. Okay. So then finally, writing it all pretty and wrapping it up with a bow, at the bottom I've got g prime of t is going to be equal to 45 times t minus 2 to the 8th over 2t plus 1 to the 10th. Now if you're wondering where that green came from, That's 5. 5 times 9 is 45. T minus 2 is being raised to the 8th, so I could just think of that as 8th. I can think of that as 8th. And then these are the same, so I can combine the exponents. And there's my final answer. So what we're looking at here is just doing a whole bunch of examples because there is absolutely no way for me to show you everything that could show up in the homework. But I'm trying to give you at least a broad possibility of what could. We have chain rule problems, but chain rule can be hidden. Chain rule can be hidden in a product. Chain rule can be hidden in a quotient. It can be the chain inside the quotient, or it can be the quotient inside the chain. Okay. What are we looking at here? Well, if you look at this, you should see a product rule, because right here, there's two things being multiplied together, but the first one is a chain rule, and the second one is a chain rule. So this is a chain times a chain. And a chain times a chain, when you take the derivative, I need product rule, but then I need the chain rule for each of those two pieces. Right? So if I call this one the first, and I call this one the second, right? So if u is 2x plus 1 to the 5th, then u prime is going to be 5 times 2x plus 1 to the 4th times 2, or 10 times 2x plus 1 to the 4th. Okay. If v, the second, is x cubed minus x plus 1 to the 4th, then v prime is going to be 4 times x cubed minus x plus 1 to the 3rd times 3x squared minus 1. And then I got to use the product rule to put that all together. And so then I know that dy dx, according to the product rule, is going to be u prime v plus u v prime. And I got to use these pieces over here to fill in all that. Okay, so what's that going to give me? U prime is 10 times 2x plus 1 to the 4th times x cubed minus x plus 1 to the 4th plus uv prime. Well, u was 2x plus 1 to the 5th times v prime, which is going to be a 4, and an x squared, a cube, minus x plus 1 cubed, and a 3x squared minus 1. And now I got to do something with this. There are two terms sitting here. This is the first term. This is the second term. There are common factors. There's a 2x plus 1 and a 2x plus 1. There's an x cubed minus x plus 1. There's an x cubed minus x plus 1. So let's factor that stuff out. So we're going to get a 2x plus 1. Let's see, smaller exponent is the 4. And we're going to get an x cubed minus x plus 1. Smaller exponent is the 3. Times, in the first term, that's all gone. One of these is left and the 10's left, so I have 10 times x cubed minus x plus 1. In the second term, the 4 is still there. The 3x squared minus 1 is still there. All of those are gone, and a 2x plus 1 is still there. Because I took 4 of them out, I had 5. Now we need to clean up inside of here. So let's look at what's going on in here. Let's see. I'm seeing 10 x cubes minus 10 x's plus 10 plus, let's see, first times first is going to give me 6x cubed times 4, so plus 24x cubed. Outer is going to give me a 3x squared times 4, so plus 12x squareds. Inner is going to give me a negative 2x times 4, so a negative 8x. And last is going to be a negative 1 times 4 is a negative 4. Okay, so dy dx, my derivative, dy dx is going to be a 2x plus 1 to the 4th times an x cubed minus x plus 1 to the third times, let's see, I've got 34x cubes. I've got 12x squareds. I've got negative 18x. And I've got positive 6. And there's my derivative. Okay, where's the calculus? Here and here. Everything else is algebra. All right, I'm in this video right here. We'll call it good and come back and do more.